I am Mr. Joel. Our topic for today is bond energies and its calculation. Let's see our learning objectives. At the end of this lesson, we will learn what bond energy is. 2. How to determine if a reaction is exothermic or endothermic using its energy change. Most substances apart from noble gases are involved in chemical bonding. For example, hydrogen forms a bond with oxygen when it forms water. Chemical bonds are forces of attraction between atoms or ions. Every chemical bonds have its unique energy called bond energies. Now, what is bond energy? Bond energy is defined as the amount of energy required to break 1 mole of the stated bond. It's simply the energy needed to break a bond. For example, the bond energy of OH single bond is 463 kilojoules per mole. This means that it requires 463 kilojoule of energy to break 1 mole of OH bonds. In order to break any bond, energy must be absorbed. Therefore, bond breaking is always an endothermic change. Conversely, energy is always released upon the formation of a bond. Therefore, bond making is always an exothermic change. In every chemical reaction, bond breaking and bond formation occurs in a region called the activated complex. Note, it's not the same as activation energy, which is the difference between the reactant and the activation complex. The activated complex determines if the reaction will be exothermic or endothermic. If the energy needed to break bonds is greater than the energy needed to make bond, the reaction will be endothermic. That means in the activated complex, the energy needed to break bond is greater than the energy need for bond formation. This also means the reaction absorbs energy than it releases. On the other hand, if the energy needed to make bond is greater than the energy needed to make bond, the reaction will be exothermic. This means the reaction releases more energy than it absorbs. How to calculate bond energies? Let's say you have a chemical reaction and also the bond energies of each molecules. In the reactant part of the equation, there are hydrogen and hydrogen bond, chlorine and chlorine bond, while in the product part you have 2 moles of hydrogen chloride bond. Let's say you are asked to calculate its energy change and determine if it's exothermic or endothermic. Step 1. Add together all the bond energies for the bonds in the reactants. This is the energy in. This is the sum of the bond energy of the reactants, that is the sum of the hydrogen-hydrogen bond and chlorine-chlorine bond. Step 2. Add together all the bond energies for the bonds in the product. This is known as the energy out. There are 2 moles of hydrogen chloride bond. Therefore, you multiply the bond energy by 2. That is 2 times 432. Step 3. Calculate the energy change, which is equal to energy in minus energy out. We have 679 minus 864. Our energy change is minus 185 kilojoule per mole. Since the energy change is negative, the reaction is exothermic. Let's take a look at this Igcse question. We are asked to calculate 1. Energy needed to break bond. 2. Energy released in making bonds. 3. The energy change.